Hi, welcome to Hashtag Math. We will discuss derivatives of all types of powers. It will all make sense. And this is what I mean by derivatives of all types of powers. So let's go one by one. Let's number them. Type 1. They have a constant base and a constant exponent. They look like, a number to a number. 5 to the second power. It could be something like 2 to the fourth power. Or pi to the third power. Or e to the fourth power, or something like e to the ln 2. All of those are numbers. Ln 2 is a number, e to the ln 2 is a number. All of these are numbers, so the derivative, it's always going to be 0. The second type is a function to a number. This is the one we have worked the most, and they look like, x to the fifth power, x to the fourth power, 3x squared plus 2x plus 1 to the 10th power, cosine x to the fourth power, or ln x to the fifth power. All of those have a variable base and a constant exponent. The third type are exponential functions, where the base is constant and the exponent is variable. So we have a number, say maybe 2, to a variable exponent, so the simplest one, 2 to the x. It's just an exponential function, a number to x. Or we can have a number like 3 to a function, because then we can use the chain rule. Something like 3 to the sine x. So that's the exponential function composed with a sine. Or we can have something like 3 to the ln x. The fourth type is a variable base to a variable exponent. This is a function raised to a function. The most simple one, which would be just the identity to the identity, or something like x squared plus 1 to the x power, or x to the square root of x. All of those are functions raised to functions, and for that we need to use logarithmic differentiation. Let's see some examples now. We have 3 expressions here. All of them are of the same type. Do you know what type is this? Yep, it's a variable base to a constant exponent. This is what we have been doing all the time. We use the power rule for derivatives. And for example, we want to derive x to the pi. Well, the pi comes to the front and subtract the exponent by 1. And that's it. The other one is again the same type because e is just a number. So to derive, we just bring e to the front and subtract the exponent by 1. And the same for x to the ln 5. You want to derive x to the ln 5. You bring ln 5 to the front and subtract 1 from the exponent. Easy. Okay, what type of power is pi to the x? Constant base, because pi is a number, to a variable exponent. And this is an exponential function. So to derive this, we just use the derivative of the exponential, which is keep the same exponential and multiply by ln of the base. And that's it. The next example, what type is it? Yep, a constant to a variable exponent. So we have a constant to a function and we want to derive that. Again, this is an exponential function, so the derivative of 3 to the x squared plus 1 is keep the same thing because it's the exponential and multiply by ln of the base, but this is a chain rule. X squared plus 1 is inside the exponential function 3 to the x. So we have to derive the inner function x squared plus 1. And so this is 3 to the x squared plus 1 ln 3 times 2x. We can write it nicer, like 2x 3 to the x squared plus 1 ln 3. And we're done. Now let's practice when we have a variable base to a variable exponent. So a function to a function. In this case, we need logarithmic differentiation. We want to derive y, and it is a function to a function, so we must apply ln on both sides to bring down the exponent and be able to derive. ln y equals ln x to the x plus 2. The exponent is going to multiply to the front, and we get ln y equals x plus 2 times ln x. I find it easier to distribute first. So ln y equals x ln x plus 2 ln x. And now we derive on both sides. On the left hand side we have the chain rule. The derivative of ln y is going to be 1 over y, y prime. And on the right hand side, we go one by one. X ln x is going to be a product rule, so we keep x. Derive ln x plus derive x, keep ln x. And the derivative of 2 ln x is just 2 over x. So we get 1 over y, y prime equals x times 1 over x, which is the derivative of ln x, plus derivative of x is 1, so we get just ln x plus 2 over x. And we multiply both sides by y to solve for y prime. The y's cancel out, so the derivative of y is going to be, y is the original function, x to the x plus 2. And let me write this a little nicer. The x's cancel out, so we get 1 plus, I'm going to write first 2 over x plus ln x. So the derivative of y equals x to the x plus 2 plus, and when we multiply x to the x plus 2 times 2 over x, there's a little cancellation. 2 times x to the x plus 2 minus 1, which is x plus 1, plus x to the x plus 2 ln x. More practice for variable-based to variable exponents, or function to a function. Again, logarithmic differentiation, you know how it starts. Take ln on both sides. So ln y equals ln of square root of x to the x power. So ln y equals x ln, but I'm going to rewrite square root of x as x to the 1/2. Now the 1/2 again comes out to the front, and we get ln y equals 1/2 x ln x. And we derive on both sides as always. So 1 over y, y prime equals 1/2 stays out. And when we derive x ln x, that is product rule. So keep x, derive ln x, plus we derive x, keep ln x. So 1 over y, y prime equals 1/2 times x times 1 over x, the derivative of ln x, plus the derivative of x is 1, so we just have ln x there. We multiply both sides by y. The y's cancel out, so the derivative of y equals, y is the original function, so this is square root of x to the x times, the x's cancel out, so this is 1 plus ln x, and this is our derivative. In our next example, we're going to continue practicing how to derive a function to a function, and here we have y equals ln x to the ln x. Go ahead and apply ln on both sides. Ln y equals ln of ln x to the ln x. The ln x comes multiplying to the front, so we get ln y equals ln x times ln of ln x, and we derive both sides. So 1 over y, y prime is going to be, what we have here is a product rule, so we keep ln x and derive ln of ln x, plus derive ln x and keep ln of ln x. Then 1 over y, y prime equals ln x, and to derive this function we have to use chain rule, this being the outer function and this being the inner function. So derive the outer function and keep the inner function there, and then multiply by the derivative of the inner function. And for the second term, we derive ln x, which is just 1 over x, and keep ln of ln x. Then 1 over y, y prime equals, the ln x cancel out here, and the derivative of ln x is 1 over x plus ln of ln x over x. We multiply both sides by y. The y's cancel out as always, and the derivative of y is going to be what? Y is the original function, ln x to the ln x times, and I'm going to write this with a common denominator because they already have it. So this is 1 plus ln of ln x. And that's our answer.